Welcome to Academic Excellence. This channel is primarily created to help you with your academic work. Please, this is a new channel. Help by subscribing and also hit up the notification bell so that at any time we uploaded any video, you get notified. Like, share, and also what? Comment. Please watch this video to the very end because you will learn a lot and it will help you greatly, right? So in today's class, we'll be talking about algebra, right? And algebra is a key topic if you want to know mathematics, right? By all means, you must know mathematics, algebra, right? So algebra, algebraic expression, right? So the other name for algebraic expression, you can just call it algebra. So you can just call it what? Algebra. Now, first of all, what is algebra? Algebra is a mathematical analysis that involves numbers and letters, right? For example, 4x plus 9 is an example of algebra. 3x plus n is an example of algebra, right? 6m plus 8 is an example of algebra. So, etc., etc. From there, let's move to the principle of algebra, right? So, the basic principles. The first principle in algebra says any number or letter that stand alone is divisible by 1, right? Or any number or letter that stand alone has an indivisible denominator of 1, right? So this is what the basic principle, the first principle in algebra says, right? Now, example, this 6 as a number that stand alone, they says what? It has what? An indivisible denominator of 1. Indivisible mean you cannot see it, but it is there, right? So you cannot see it, but it is there. So there's a what? Indivisible denominator of 1 here. You see, that's what the principle is saying. So it's there, right? But now you go again. There's indivisible denominator of 1 here, right? It is there. Any number that stands alone has an indivisible denominator of 1, right? And also, any letter that stands alone has an indivisible denominator of 1. So you cannot see it, but what? It is there. Here again, it is what? There. So all these numbers and letters that stand alone has an indivisible denominator of 1. So this is what the first principle in algebra is trying to say, right? And now we move to the second principle of algebra. The second principle of algebra says any number or letter that stands alone has an invisible positive sign. This is what the second principle says. Any number or letter that stands alone has an invisible positive sign. For example, this number 6 that stands alone, algebra, the second principle says it has what? A positive sign. Meaning, if it's invisible, meaning you cannot see it, but what? It is there. This number 8 that stands alone has a what? Positive sign. You see, you cannot see it, but it's what? It is there, right? And also this number, or sorry, this letter that stands alone has a what? A positive sign. You cannot see it, but it's what? It is there. A positive sign. That's why we say invisible positive sign, right? And also what? This letter X that stands alone has a what? A positive sign. You see. So this is what the second principle of algebra is saying. Any number or letter that stands alone has what? A positive sign. So next, we move to the third principle of algebra. And the third principle of algebra says, right? Says any letter that stands alone has a coefficient of 1, right? Any letter that stands alone, a coefficient of 1, right? Example of letters: letter X, Y, what? M, etc. So now they say this letter X that stand alone, right, has a coefficient of 1. So it always has one, invincible coefficient of 1, right? So always this letter X has a coefficient of 1. This letter Y has a what? A coefficient of 1. This letter M has a what? A coefficient of what? 1. So any letter that stand alone has a coefficient of 1. But this one, they are invisible, right? You cannot see them, but what? They are what? They are there, right? This is what the principle, the third principle of algebra is saying. Any letter or number that stand alone has a what? A coefficient of 1. So any letter is not number that stand alone has a coefficient of 1. So these are the letters. Now we move to the analysis of all these three principles that we have just stated. We move down to the analysis. So the analysis of what? The principles in algebra. Now, let's try to take just a number or a letter and try to analyze. Now let's say we take letter X. This letter X, right, with related to the three principles, says, first of all, the first principle, which says what? Any number or letter that stand alone is what? Has an indivisible denominator of 1. So this letter X has an indivisible denominator of 1. So letter X always has what? An indivisible denominator of 1. Wherein the second principle tell you about what? The other principle that what? Any letter or number that stand alone has what? Has a coefficient of 1, right? So it has a invisible positive sign. A number or letter that stand alone has a what? Invisible positive sign. So it has a positive sign. And the last one says what? Any letter that stand alone has a what? A coefficient of 1. So these are the three principles in algebra, right, of the analysis. So any letter that you see that stand alone in mathematics, it has a denominator of 1, a coefficient of 1, and a positive sign. So this is the three. Now let's come for number. Let me say number 6, right? This number 6 that stand alone, according to the principle of algebra, we says what? It has a what? An indivisible denominator of 1. And also is what? It has a what? An indivisible positive sign here. You see? So this is what the analysis in algebra is trying to say concerning numbers on and also what? Letters. So these are the three things that any letter you can see in the mathematics that they have. And any number you can see, these are the two things that they have. So now we move now to what? Addition and subtraction of algebra. So now, in addition and subtraction of algebra, what you are supposed to first note? Why? 1. Always a number, right, appeared before a letter, especially if they are combined together. For example, you say what? 6x, 3m, 2y. You see? So always a number first appear before a letter. So this is what you must first note. But you don't say what? mx6. No, it's wrong, right? You don't say m3. No, it's wrong. You don't say y2. No. So the appropriate way to say it is what? 6m. First call the number and what? Followed by what? The letter 3m, 2y. So you see, that's how you recall numbers, especially digits that have both numbers and letter. That's how we call them. We call first the number followed by what? The letter, right? This what you must first note in addition, right? So in algebra, right? Now we go. How to add and subtract in algebra. First of all, how to add and subtract in algebra. Now if you want to add and subtract in algebra, right? We always add like terms. Always add and subtract what? Like terms. Anything that they are not like terms, you must not what? Add them. You get it? Anything that they are not like terms, you must not. Now, how to identify like terms? Remember, I says anything that are not like terms, you must not add them in algebra. You only add what? Like terms. Now, how to identify like terms? Now, like terms are identified in two ways. One, in numbers, in letter and power, right? So the criteria must be like terms must have what? The same letter and what? Same number and same power. power. You see, so they must have what? The same letter and the same power. Example, if you see 3x square plus 2x square, so these are like terms because they have the same letter x, power 2, so these are like terms. This is how to identify them. If you see 8m plus 6m, these are what? Like terms. Letter m, power 1. Do you see it? These are all what? Like terms. But if you see 2x square plus 3x, these are not like terms. Why? Same letter but what? Different power. Do you see? This is power 2, this is power 1. So anytime they do not have the same power, they are not like terms, and you don't have the right to add them, right? So this is how to identify what? Like terms. If you see 3m plus 2x, if they are not like terms, right? M and what? X, so different letters, so they are not like terms. So always like terms must have the same letter and the same power. This is what you must first understand, right? Now that you know how to identify like terms, now we move what? How to add like terms. For example, 3x square plus 4x square. These are like terms. So how can you add them? So since it is plus, what you see, you only add the number and take one of the letters to represent them all. For example, you say 3 plus 4, which will give us what? 7x square. You see, that's why you make only like terms. Okay, now we say m plus 3m. How can you add them? Remember, the first principle in algebra says any letter that stands alone has a what? A coefficient of 1. So there's an invisible 1 here, right? The principle. So now how to add them? M, N, so they are like terms. Power 1. What you see? So say this one that is here, 1 plus 3, which will give us what? 4. So you write what? You take one of the letter to represent them all. You say what? 4m. This is how to add like terms. You always add the number and take one of the letter to what? Represent them all. You get it? Good. Now we move to the first example in addition and subtraction of algebra. Remember, with all the explanation that I've just gave you, you're able to what? To solve any kind of example. Now we are going to apply them. Example 1, right? Simplify what? 3x plus 9y plus 2x minus 5y. So we say what? Solution. Now how are you going to do to simplify them? Remember, I spoke about like terms, right? And now, first of all, anytime you have mathematics, first look for what like terms and try to what? Bring them together. Like terms mean they are the same, so bring them together. So we say what? 3x plus 9y plus 2x minus 5y. Now you bring them. X, power 1. So they are like terms, so you bring them together. 3x plus 2x. You see? Y, power 1. So they are what? Like terms. You bring them together. Plus 9y minus 5y. You see? Now, you are supposed to what? Add now like terms, right? We add them now. How did I say to like? You add the numbers and take one of the letters to what? Represent both the two x. So 3 plus 2 is what? 5, right? 5x. Plus 9 minus 2 is what? 9 minus 2 is how many? Just subtract the numbers and take one of the letters to represent the odd. So 9 minus 2 is how many? 4, which will give us what? 4y. You see? So this is the answer. This is x. This is y. So they are not like terms. So once they are not like terms, it's there you're supposed to stop solving. You see? This is your what? Answer for this particular question, right? So these outcomes, right? So now we move to example 2. Now, this is example 2. Now example 2, simplify what? 5m plus 6 minus 8k plus 4m minus 7 plus 2m square plus 2k. Now how to do it? First of all, we write it. 5m plus 6 minus 8k, right? Plus 4m minus 7 plus 2m square plus what? 2k, right? Now what are you going to do? Collect like terms, right? You know now what are like terms? The same letter and what? The same powers. Good. Now we go. We take letter m power 1, letter m power 1. So we bring them together. So say 5m what plus 4m. We come again. Same letter again. Minus 8k power 1, k power 1, k power 1. So you see what? 8k what? Plus 2k. Right? Good. Now you go. Now we have collected all the m and all the k. Now we go again. This is m, but this is m power 2. So they are not like terms. So you should not include them. Right? So plus what? 2m square. Right? What? Plus 6 minus 7. Do you see it? So these are all. Now we have arranged them in what? Like terms. So now you add the like terms. 5 plus 4 is what? 9. So 9m. You take one of the letters to represent the 2m. Right? Minus 8 plus 2 is what? You subtract them. Which will give us what? Minus 6. Right? And what? Take one of the letters to represent the all. So you take k to represent the 2. Now what is here? This is m square plus 2m square. What? Plus what? 6 minus 7. It will give us what? Minus 1. Do you see it? So minus 1. So this is it. Now you have to arrange them in order of what? Magnitude, right? So meaning what? Decreasing power, right? So always learn to put the highest power in front. So we bring the 2. So say 2m square plus what? Plus 9m minus 6k minus what? 1. So this is your answer, right? Remember, this is m, but they are not like terms because of the power. This is power 2, this is power 1. So they are not like terms. So this is how to add. Please, if you don't understand, please play the video so that you understand it.